Hey guys, this is Ben with Paessler. In this PRTG tutorial, we're talking about bandwidth monitoring with our NetFlow and Packetsniffing sensors. Okay, so let's talk bandwidth monitoring with our packet sniffer and our various flow receiver sensors. Let's start first with one of the more popular ones, that being NetFlow. We do support NetFlow version 5 and version 9. I'm going to go with a NetFlow version 9 sensor. So I'm going to go over here and I'm going to bring up just a plain Jane NetFlow V9 sensor. This is what it's going to look like with no customization, just out of the box, if you will. It's going to give us our various channels here broken up by the most popular protocols we have. So HTTP, HTTPS, FTP, mail, NetBIOS, www, things like that. Now, if I go into the settings, I do have some options where I can break that up a little bit. You'll see down here in channel configuration, I can expand that. So now instead of just a web group, I get HTTP and HTTPS traffic. Instead of a mail group, I get IMAP, POP3, SNMP. Rinse and repeat for the rest of them. You can see how it breaks them up there. The other things I can do in settings while I'm in here, I can change the name of the sensor. So if I've got something else I want to name it, I can change the port. The default port is not always something you want to keep, especially if you're using multiple NetFlow sensors. You may want to have different NetFlow sensors going different places, so you may want to shift the ports around a little bit. The sender IP is important if you have a device that sends NetFlow out an interface that PRTG is not aware of. So let's say you're using a management interface for the IP that PRTG knows about for the device, but let's say you're using a different interface to actually send the NetFlow out of. This helps PRTG to recognize where it's coming from. Of course, now we select here where we want to receive it. If your server has multiple network cards, you'll have different IPs here. In this case, we just have a single IP. The sampling mode, this allows you to cache the results to disk. We really don't recommend this unless you're looking to debug some things or get into the flow rules, which is something I'll go over here in a little bit. Then the log stream data to disk for debugging. Again, this is something only someone in support would ask you to do for a support option. And the last thing I skipped over here that's really important, your active flow timeout. Your active flow timeout is something that you will set on your device. It needs to match in PRTG. Right here we've got it set to 0 minutes, so it's a really tight timeout. The default that I see for most devices is 15 minutes. The filtering, just like with other receiver sensors like the SNMP trap receiver or the syslog receiver, we can do include and exclude filtering. We have a lot of fields available for NetFlow. The basic ones are listed right here, and then the additional ones for NetFlow 9 are listed here. Now you'll see with SFlow, JFlow, and IPFix that those additional fields will differ a little bit. It's just different technologies allow for different things to be filtered. We can populate our include and exclude, works the same way. We can use Boolean operators. We can populate both of them, none of them, or one or the other. So now I'm going to go back to the overview tab here because there's a few things I want to highlight as far as our top lists go. When you create one of these sensors, be it a NetFlow sensor, SFlow, JFlow, IPFix, or a packet sniffer sensor, you're going to get these top lists. The 3 by default that you get are top talkers, top connections, top protocols. Let's dive into top talkers. So you can see here with the top talkers, I get this nice little graph over here that's kind of a visual representation of my bandwidth pipe for a particular period in time. In this case here, the default top list does 15-minute intervals. So I can see here the date and the time, and this is the live top list, so it's going to tell me how far I am into it. In this case here, we're 63% complete with this period. Next to it, it's going to give me the data table. So I have the visual representation. Over here, I have the actual data table where I can read the verbose URLs as well as IP addresses. PRTG will attempt to do DNS resolution. As long as it can resolve DNS, it will resolve DNS and include the DNS name. If it can't resolve it, it'll just give you the IP address. It'll also give you the bytes, so how much traffic happened between those hosts, and the percentage here is how much of the bandwidth it equates to for that period in time. Let's say I want to go back in time and look earlier. You'll see over here on the side, we break it up by day and then by interval. So let me go back to 5:30. So now you can see here, this interface is completely interactive here. If I hover over any one of these, you see it'll isolate that for me in the graph. It'll turn all the other ones dim, so it makes it easier to visualize what's going on. And then over here in the data table, I can hover over any one of them. It makes them a little bit bigger. And then I also can scroll down to the bottom to go to the next page. So in this case here, I have 100 in this list. I'm just looking at the first 50. Here's how I would click on this to get to the next 50. One thing that's worth mentioning here, it's a little too granular at this level, but some of the other top lists may not be as granular. What you can see here, when our colors impede on one another, that lets us know that there's crosstalk going on here. So like in this case here, this particular IP address is talking to this particular IP address. That's what the traffic's representing to me. If it's going outbound, then it won't do that. So in this case here, this one device over here, the one that's eating up most of the bandwidth, it's in the other field because we can't classify it by default, but it's going outbound. So it's not talking to any of these others. You can see here, it's real easy to see we have a lot of inter-network crosstalk. This helps to understand better how busy your devices are, and especially how busy they are in talking to one another. How much inter-network traffic do you have in relation to traffic that is going out or coming in and not between two devices that are on your network? Top connections, very, very similar. The only thing different, we add source destination port, the protocol number, to the existing data table, and then it's just the exact same. You can go back in time, you can do anything you want to in terms of, looking at it. One other thing worth mentioning, when you go back in time here, you can always click on one of those links there, and it will generate this in a much larger interface. It actually runs it into a report diagram, and this is real easy to then export out if you wanted to do a PDF or anything like that to get a better idea, better visual understanding of what's happening. The last one, top protocols, I'll just touch on real quick. It's just going to show you the top protocols that are going on here. One thing on this various one that I want to mention, we'll have a link in the description to our knowledge base article that talks about flow rules. So by default, PRTG only identifies some of the most popular protocols. We do that so that we can save resources. Anyone who's ever worked with a full-blown web traffic analyzer, like a Barracuda or a WebSense or anything like that, knows that those devices all have one thing in common. They are usually a dedicated device, whether it's a virtual appliance or a real appliance, and they physically go in between your internet connection and your network. They are literally tapping your network. There's a reason for that. You need a lot of processing power, and you need a dedicated device if you're going to do packet level identification, tracking back to users, things like that. That is not what NetFlow is, nor SFlow, JFlow, or IPFix. These are technologies that sample the data on the device and then generate those flow packets and send them to a collector, in this case PRTG. We don't classify that because if we did, PRTG would need a lot more processing power than it does right now. We do that so that PRTG stays light and nimble. It can run on servers that you don't have to invest a large amount of money and capital into, and it keeps the entire system running well so that you can have NetFlow and monitor SNMP and monitor WMI and monitor all the other different protocols and systems that you want to monitor with your monitoring system. Now, that doesn't mean we can't fine tune it and tweak it. You'll see in that knowledge base article, we can go into our flow rules and we can define some additional protocols. Say you're in an environment where you have a lot of a particular protocol. It could be anything non-standard. Or let's say you have a lot of traffic that's on a various port. These are things you can go in, you can add to these flow rules, and then you can give it a name. You can give it a descriptor so that it would show up as a different protocol listed on here. That can really come in handy, especially if you have certain networks that are not standard, specialized networks. Think about like networks for your security cameras. Think about IP phone networks. Think about networks that are for media broadcast, multicast video, unicast video, things like that. This is where the NetFlow or any flow sensor can really start to shine in terms of helping you understand how much that traffic is really taking up from the bandwidth during that period in time. One thing that's worth mentioning too here, you probably see it on the screen, the Toplist has continued to update here. So we've actually entered a new period, 7 a.m. to 7:15 a.m., and now we're 8% into this. Does this automatically. I don't have to ask it to do it or anything like that. As it receives flow packets, it's going to automatically update that with the new flow packets. So it's nice that while I'm in this interface here, PRTG is consistently giving you new data. And you can always go back in time to look at a period, but if you're looking at the live top list will keep updating as you look at it. One more thing to mention when we're talking about top lists is that we can add our own custom top list. This is really, really handy when it comes to defining a view that matters to you. You know, top talkers, top connections, top protocols, those are fairly industry standards when it comes to monitoring NetFlow technologies or other flow technologies. But it's not always exactly what you need. So if I click on Add Top List, I get this screen here, and I can give it a name. And let's say we wanted to do one that's just source port. So what I'm going to do is I'm going to do Custom. And now you'll see I have all the fields available to me. I'm going to do source port, and then I'm going to do source IP, destination IP, and then I think that's all we'll do on this one here. My period that I can cover, this is the period that the top list covers. By default, it's 15 minutes. I can make it as big as I want though, or as small as I want. I wouldn't go lower than 5 minutes, mainly because asking the flow sensor to constantly update, there's a good chance you may not get a whole lot of information based on what your sampling method is, or what your sampling settings are. So I'll keep this at 15 minutes, and the top count I'll keep at 100, but I could make that as small or as big as I want to as well. Reverse DNS lookup or no reverse DNS lookup. Obviously, if you turn off reverse DNS, it's going to be much faster. The probe core data transfer. If I'm on a remote probe, and let's say that link on the remote probe to the core server is not exactly a robust link, what I can have the sensor do is wait until that period ends, take all the data together, and then send it as one push rather than just send little bits one after another. Totally up to you. In this case here, we're on a very fast network in here, so I'll do according to sensor intervals, so it'll update for me as new packet info comes in. The memory limit, this is the top list memory. This is just a piece of memory that we set aside for the probe in terms of just memory that it keeps for the top list. 10 megabytes is more than enough. You got to remember, these NetFlow packets are small. They're just carrying little bits of data that have whatever fields you want. And I've only selected 3 fields here. So 10 megabytes is really all you need for it. I'll click on Save. It'll generate it for me. And then one thing that's really nice about this, when I create a source, or when I create a top list that is custom, I'm dealing with a data set I already have, which means that over time, this will actually start to pick up all that data I've already got. Now, in this case, it's going to take a little bit, so we'll probably come back to it, but you will see that it'll be able to backfill everything I've already established, the entire data set that I'm already keeping. While we're waiting on that, I want to talk briefly on a packet sniffing sensor, because it is a little bit different in terms of how it's set up. So we'll go to P and we'll go to packet sniffer. So look and feel, very, very similar to that of the flow sensors that we talked about. But when we go into settings, a few things differ here. We do have our include and exclude filter, but here's where we have our network adapters. Now, if you only have a single network adapter on your PRTG server, then unfortunately, you're stuck with that in terms of packet sniffing. It's not really what we designed the packet sniffer sensor for, though. The packet sniffer sensor really is something that we expect you to use on a server where you have multiple NICs, where you can plug one of those NICs into like a span port on a switch, and then actually get monitoring data to come through. Essentially, the same way you would do with like a Wireshark, we expect you to use the packet sniffing sensor very similar to that, and either use it to collect data to build top lists, or use the filters. Make it work for you. If there's something that you're looking to get, rather than sitting all day with a laptop in your lap plugged into a switch in a data center with Wireshark running, hoping that you catch whatever anomaly you're looking for, throw it in a filter. Let the packet sniffing sensor sit there and do that for you so that you don't have to waste all that time. Again, same thing as far as the groups go, and this also follows the same flow rules as well. So any flow rules you establish are global for all those sensors. One other thing I want to touch on before we go back to our flow sensor, you'll see that some of these sensors have custom in parentheses next to them. Those sensors are very similar to what we have here, but they differ in one way. And I want to show you that right now by going to one of our custom packet sniffing sensors. Currently, this one's an unknown status, but I can still explain what I'm trying to get across here. If I go to settings, you'll see the big difference is that there is no channel definition that I just click through. The channel definition is completely up to you. You may have a case where you don't care about web traffic, mail traffic, net BIOS, infrastructure, all that's industry standard stuff. Let's say you're just interested in one thing and one thing only, or maybe a grouping of things, but you don't want to see all that other noise. You just want to see that. Here's where you can create your own channel definition. The way to set it up is very simple. The manual page here goes in depth on how to write the channel definitions. It's the same as it would be in any other one, especially if you're used to using our Sensor Factory sensor. With the channel definition, you're just going to build out your channel definitions as you would, just like you would with the Sensor Factory sensor. The same applies to our NetFlow sensors as well, SFlow, JFlow, IPFix. And using that, you can start to really fine-tune these sensors to work how you want them to work. Instead of you just being okay with how they're working, make them work for you. Customize them. Make them give you the data you're looking for. Otherwise, what's the point? Having data at hand and bending around that is one thing. But having data and making it work for you, well, that's what we're trying to do for you. That's how we're trying to empower you. Let's go check on that NetFlow sensor. So in this case, it's taking a little longer than I wanted it to, but eventually it will come through. This sensor actually has quite a bit of data, so it's probably going to take a while for that one top list to come through. So, of course, your experience will be different from mine. If you have any questions, please feel free to reach out to us, support@paessler.com. Thanks guys for watching, and we'll catch you in the next one.
If you find this video helpful, feel free to like it and consider watching our other videos on our channel. If you still have questions, please contact support@paessler.com, and always feel free to comment for feedback or suggestions for other topics. Thank you.